Hello students, in this section we are going to discuss the essential difference between speed and velocity, and then we will discuss the difference between mass and weight. So let's start with this particular topic, speed and velocity. Let's try to bring out the essential point of difference between these two, right? So as we are aware, magnitude is only the thing which is associated with speed. It has no direction. So basically what I mean to say is that speed is a scalar quantity having only magnitude but no direction. So it is a scalar quantity. While on the other hand, velocity, it possesses both magnitude as well as direction. Therefore, it must be a vector quantity which possesses both magnitude as well as direction. So velocity is a vector quantity. This is the fundamental difference between these two. Okay, next, let's concentrate upon the definition. What actually speed is? What's the rate of change in the position of a body? That's speed. Speed means how fast a body can move or how fast a body is moving. That is denoted by speed, right? If you are only talking about magnitude. And when also direction comes into play, when both magnitude and direction both are involved, then that becomes velocity, right? So speed actually is defined as the time rate change in the distance covered by the body. The time rate change in the distance covered by the body. I'll give you an example. Suppose this is it. Let us consider at t equals to t1. Suppose the body is over here and this distance is x1. Suppose at some later instant t equals to t2, the body is at point B. It is x2. So during time interval t2 minus t1, it has covered a distance of x2 minus x1. Understood now? So what I have considered is a body is moving along the positive x direction. Suppose at instant t equals t1, body is at point A, and at some other instant at t equals t2, body is at point B. The distance of point A and point B from the origin is x1 and x2 respectively. So during this time, the time which has elapsed, during the time in which the body moves from A to B, that is t2 minus t1, during this time t2 minus t1, the body has covered this path, right? So speed is given by distance covered by the body per unit time. So mathematically, speed may be represented as x2 minus x1. This is the length of the path covered by the body in time t2 minus t1. So considering this example, we can write mathematically speed as total distance covered divided by total time taken, right? So it is actually total distance covered by the body divided by the total time taken by the body to cover that distance. So speed is defined as the time rate change in the distance covered by the body. So that is how speed is defined. Distance is a scalar quantity, time is a scalar quantity, so speed is also a scalar quantity. Obviously having only magnitude but no direction. What about velocity then? Just make use of common sense. It is the time rate change in the distance, that is speed. The time rate change in the displacement of the body, that will be known as its velocity. So simply in place of distance you need to write displacement, right? So time rate change in the displacement of the body is known as its velocity. So velocity is actually defined as displacement divided by time. This is the formula for the velocity. So theoretically the velocity of the body is defined as the time rate change in its displacement, right? Displacement, as you are aware, is a vector quantity possessing both magnitude as well as direction. So velocity must also be a vector quantity having both magnitude as well as direction. Okay. Speed, as you are aware, it is dependent on distance covered. Time rate change in the distance, that is speed. Now distance we have discussed in the previous section, it can't be zero. If a body is in motion, it will possess some sort of finite value of speed, isn't it? So Whenever a body is in motion, the distance can't be zero. The distance is never negative. It is always positive quantity. So since distance is always positive, therefore speed is also a positive quantity. Speed can't be negative. It can't be zero if the body is in motion. So it is a positive quantity. It has some positive finite value. So speed of a body is always greater than zero. Greater than zero means it can attain only positive value. Right? Okay. Regarding velocity. Now displacement we are aware. We have discussed some numericals as well. Displacement can be zero. It can be negative, and obviously it can be positive. So velocity of a body can also have all the three values. It can be either negative, positive, or it can even be zero. So velocity of a body can be greater than zero, it can be less than zero, or even velocity of a body can be zero. So all the three cases are possible out here, right? When the displacement is zero, the velocity will be also zero. When the displacement is zero, when the initial position of the body coincides with its final position. So in such a scenario, displacement of the body is zero. Whenever displacement would be zero, then the velocity of the body will also be zero. Clear? Whenever the displacement is negative, the velocity will also be negative. Whenever the displacement of the body is positive, the velocity of the body will also be positive. Right? Now one thing to be noted is that if a body moves along a straight path, if a body is moving along a straight line, then I have told you distance of that body would be always equal to its displacement. Now when distance of the body equals to its displacement, then speed of that body would be equal to its velocity. So this is a special case. If distance covered by a body is equal to its displacement, and it is possible only when the body moves along a straight path. Body moves along a straight path. It is then only that the distance of the body can be equal to its displacement. Then the speed of the body would be equal to its velocity. This is a very, very important conclusion. And also we are aware distance is always greater than or equal to displacement. Similarly, speed of a body should be greater than or equal to its velocity. That is, since distance is greater than or equal to its displacement of the body. Therefore, speed must be also greater than or equal to the velocity of the body. When these two will become equal? When the body moves along a straight path. That is when the distance of the body is equal to the displacement covered by the body. Therefore, from these two we can conclude a very important statement. That is, the ratio of speed to the velocity of a body is always greater than or equal to unity. This is a very, very important expression. The ratio of speed to the velocity of a body is always greater than or equal to 1. And speed, velocity, both have SI unit of meter per second. Distance or displacement both are measured in meters in SI, and time is measured in second. So in SI both has the same units, meter per second. In CGS both speed and velocity will have unit of centimeter per second. It will have unit of centimeter per second. So these are some essential points of difference between speed and velocity. We can discuss the difference between mass and weight as well. And in the next episode, we will discuss numericals based on speed and velocity. So, proceeding, let's bring out essential point of difference between mass and weight. Mass, it's a familiar term. You must have heard about this term in your junior classes as well. All the bodies, every body is made up of atoms and molecules. And you are aware of the fundamental structure of an atom. All bodies are made up of atoms and molecules, and each atom contains a central positive charge, central positive core known as nucleus, which is positively charged, surrounded by negatively charged electrons. So that's the fundamental structure of an atom, right? So what I mean to say is that every body possesses some sort of matter So the amount of matter possessed by a body or contained in a body is known as its mass. So this is the first definition. Mass of a body is defined as the total amount of matter. It is defined as the total amount of matter contained in the body. That is mass. While weight is a force. Now look, this is an object. If I release it, it will certainly fall down. Why? Because the earth is attracting this body towards its center. And that pull, that gravitational pull by the earth is known as the weight of this body. So weight of a body is defined as the gravitational pull or the force with which earth attracts the body towards its center. That is known as its weight. We'll discuss the term in detail in the unit gravitation. Right? So weight is actually the force or the pull. Which pull I am talking about is gravitational pull. So weight of a body is defined as the pull or the force with which earth exerts a force on the body towards its center. That is known as the weight of a body. And actually weight of a body is given by the mass of the body into acceleration, and this will be acceleration due to gravity. Acceleration due to gravity. It is represented by small letter g. We will discuss it in the subsequent chapters. So W is equal to m into small g. Small g denotes the acceleration due to gravity. There is an entire chapter dedicated to this particular topic. So we will discuss it in detail. Now simply we are trying to bring out the essential point of difference between mass and weight. Right? So basically this is the amount of matter and there is a force with which earth attracts a body towards its center. Mass is a scalar quantity. It gives a measure of the amount of matter only, just the magnitude, just the numerical value, right? The amount of matter. So no direction is involved over here. So obviously mass is a scalar quantity. While on the other hand, weight, the force, it acts in a particular direction, and that direction is along the line towards the center of the earth. So direction is involved in this case, right? Direction is involved in this case. So weight possesses both magnitude as well as direction. Therefore, weight is a vector quantity. Third, SI unit of mass, it is kg. CGS unit of mass, we discussed it, it is gram. While the SI unit of weight is Newton. Remember, weight is a force, so its SI unit is Newton. CGS unit of force is dyne. And 1 Newton is 10 raised to power 5 dyne. This is the relationship. Right? Here the relationship is 1 kg is equal to 1000 gram. Clear? Next, mass of a body. It can never be zero. As I have told you, every body is made up of matter. So how can the mass of a body be zero? It is never possible. The mass of a body is having a positive finite value. The mass of a body has positive finite value. It can never be zero. Its value is always greater than zero. That is, it should have always positive finite value. While on the other hand, the weight of a body, it does depend upon acceleration due to gravity. And in the subsequent chapters we will discuss this value of g varies, or rather it depends on various factors. It depends on altitude, it depends upon depth, it depends upon latitude, it depends upon the shape of the earth. So the value of g at different places, at different points is different. So if the value of g varies, the weight of the body will also vary. So what I mean to say is that while mass of a body is constant, but weight of a body is not constant. Weight of a body depends upon acceleration due to gravity, and thus it also changes from place to place. So weight of a body is not constant. Weight of a body is not constant. It varies with the change in the value of G. Look, at a place where the value of G becomes 0, G is the acceleration due to gravity. At a place where G becomes 0, weight of the body will also become 0. So, if at a place where small g is equal to 0, then weight of any body would be also equal to 0. And here I must mention you a very important fact. We will mathematically verify this fact as well. But for now, just remember this. The acceleration due to gravity at the center of the earth is 0. So, the weight of any body at the center of the earth will be also 0. Suppose this is a pen, there is a marker, its mass is suppose 10 gram, right? Its mass is 10 gram. This is the mass in CGS, right? It will be 10 by 1000 kg in SI. It is taken at the center of the earth. So what will be the mass of this pen? It will remain same because mass doesn't change, it remains constant. So at the center of the earth, its mass, the amount of matter contained by this pen will remain same. That will be 10 gram. But what will be the weight of this pen? It will become 0. Because weight depends upon the value of acceleration due to gravity, that is small g. And at the center of the earth, small g is 0. So mark my words, mass of a body is constant anywhere, any place. The mass of a body will always be constant in mechanics, right? While on the other hand, the weight of a body varies with the value of small g. At the center of the earth, the weight of any body is 0. Clear? So this was a very important concept and you need to go through it thoroughly. So that's it for this lecture. We will continue in the next one.